Welcome to iLectureOnline, and here's a really fun topic, sound and sound waves, and especially when we try to answer the question, what is sound? Because most of us don't have a good picture of what that is. Now, my drawing skills aren't that good, but hopefully I can explain it well enough so you can understand it. Let's try. So let's say we have a person here that has a hammer in their hand and they hit the table. Now you know that when you see somebody hit a table or hit a drum, you hear a sound. Well, how does that work? Well, when someone hits the table, that table top will be depressed and will try to restore itself in its natural place, but it'll start some oscillatory motion. So the table will start vibrating up and down at its natural frequency. Of course, it'll only do that for a very short period of time. And of course, that's why when you hit a table, you only hear a momentary sound and then the sound is gone. So once the table is oscillating that, even for a small portion of a second, what it does is as the tabletop goes up and down, it pushes against the air molecules right above it. So it compresses those air molecules. And that compression then moves through the air as a sound wave. So you can see then that as the table goes back down, there will be like a rarefaction, as they call it. There will be a region where the pressure goes down, then the table comes back up, it compresses it. So we have regions in the air that have compressed air and rarefied air, compressed air and rarefied air where the pressure goes up and down and up and down. And so you can see the regions where we have compressed air, regions where we have rarefied air. So we call these compressions and we call these rarefactions. And those go radially outward in all directions. So eventually, these compressions and rarefactions, they reach somebody that has an ear, and the ear has an ear canal. So these compressions go inside the ear canal and bump against the eardrum. And so the eardrum begins to vibrate at the very same frequency as the frequency of these air compressions. Now, for different surfaces, the vibrations will be at different frequencies, and therefore you'll create different frequencies of sound waves. So once they get into the eardrum begins to vibrate at the same frequency as the air molecules are vibrating. The eardrum is connected to something called a hammer. That hammer will then start vibrating at the same frequency as the eardrum. It'll slime into a little bone called the anvil, and then the anvil, which is connected to the stirrup, is then connected to something called the cochlea, and it kind of looks like a snail shell. And inside the snail shell, which has fluid in it like that, and of course there's some other parts to the stirrup here that also helps us keep our balance, but that's a different thing. But inside this cochlea, which is like a shell has fluid in it, there are these little cilia, these little hairs. And these hairs are very sensitive to vibrations in the fluid, which are carried through all this, through the anvil, into the cochlea. Now it turns out each of these little hairs is sensitive to a different frequency. So we have lower frequencies to higher frequencies as you go further in. And then each of these cilia is connected to a nerve ending, which then comes together into a nerve bundle that goes to the brain. So only certainly these hairs will begin to flutter back and forth as a response of the frequencies that go into this cochlea. So you hear high frequency sound. Some of these will then be responsive to it. Low frequency sounds, different hairs. So the cilia are the ones that determine what the frequency of the sound is and send that message through the nerve bundle to the brain saying, I have noticed some frequency at this frequency. What the brain then does, it takes that and turns that into a sound. And that's why we hear a sound. Marvelous technique, marvelous way in which this works. But until it reaches the brain, it just vibrations. The brain is actually the organ in our bodies that turns it into sound and into something that we can recognize. So that is what sound waves are, and that is what sound is. So really, even though they call it sound waves because they then eventually produce a sound in somebody's brain, they're just simply compression waves inside the air until some brain interprets it as sound. So it's kind of interesting when you think about that. So there you go. That is what sound is in a nutshell. And in the next so many videos, we'll talk a little bit more about the details and, of course, the physics about what sound is.